Hey students, this is lesson 10.6, trigonometric ratios. We are going to learn how to find and use trigonometric ratios. Go ahead and do the review. This is kind of important. I'll check back with you. All right, some things you need to know, what we mean when we say sine, cosine, and tangent. Sine is the opposite sine of an angle, A being the angle. The sine is the opposite leg over the hypotenuse, that ratio. And the opposite leg is, so if A is right here, then the opposite leg is the one that's across from it. And the adjacent leg is the one that's next to it, which is that green line. So notice the color coding here. All right, study those a second. Go ahead and fill in the words hypotenuse, opposite leg, and adjacent leg for angle C. I'll check back with you. Okay, so let's just get used to finding those ratios. Remember that we're talking about a ratio that is in respect to a certain angle. And let's start with the sine of A. And remember that the sine of A is the leg opposite A over the hypotenuse. So the sine of the A, the leg opposite, would be the 20. And the hypotenuse, of course, is 25. So 20 over 25, and then just simplify that. Then the cosine of A is equal to the side, the leg adjacent to A, divided by the hypotenuse. The leg adjacent to A is the other one. That's this one, 15. Hypotenuse is the same, 25. And that simplifies to 3/5. And then the tangent of A is equal to the ratio of the two legs, the leg opposite A divided by the leg adjacent to A. Okay, and opposite A is 20. Adjacent to A is 15, and that simplifies to 1/3. All right, you try that. Now you can actually find these ratios on your calculator fairly easily, and they're the built-in functions on your calculator, and I'll show you that. One thing you have to know though, if you're talking about the ratios as angles, then we need to put the calculator in the degree mode. The way you do that is you press the mode button and change your calculator to the degree mode. Okay, and then you can find any ratio you want. And here, problem 2, we're finding the sine of 39, so you just press sine and then enter your number 39, and now it knows it's a degree that you're looking for, the ratio for, and it gives you the ratio, and it's 0.6293. And so the sine of 39 is equal to, approximately equal to 0.629 to the nearest thousand. All right, we're going to use that calculator to help us find the missing side length, and we want to find x. Now what we want to notice is what relationship does it have with the angle, and x is a leg, and it's a leg opposite the 71-degree angle. 20 is the hypotenuse, so we have the leg, we have the opposite leg, and we have the hypotenuse. The trigonometric ratio we want to use here is the sine, because the sine of A is the leg opposite divided by the hypotenuse. And we can just substitute our numbers in and solve for the missing number. So we're going to put, for the sine of A, we're going to put the angle, which is 71 degrees. A is the angle. I'll mark that there. So the sine of 71 degrees is equal to the side opposite, which is x, over the hypotenuse, which is 20. And we're just going to think of this as a proportion. So that means that 20 times the sine of 71 degrees is equal to x times 1, which is x. And then I'm just going to go to my calculator and have it calculate that. We want 20 times the sine of 71. But you got to make sure that your calculator is in degree mode, which I know it is because I just put it in degree mode. But 20 times the sine of 71, enter, is 18.9. Approximately, the nearest 10. And then just look at your triangle, make sure that makes sense. The leg has to be shorter than the hypotenuse in a right triangle, so that seems to make sense. So our answer is about 18.9. Go ahead, you try that. All right. If you know the legs of two sides of a right triangle, you can use the trigonometric to find the measure of the angle by doing the inverse trigonometric. And you'll find those on your calculator by just pressing second and then whichever one you want, like sine. So that's the sine inverse. So that'll turn a ratio into an angle for you. And just to show you how that works here, it says the hypotenuse is 8 feet long and the adjacent side is 5 feet long to this angle that we're looking. So that would look like this on a triangle. So the hypotenuse is 8, and let's say we're trying to find this angle A. The side adjacent is 5, so this angle here. So we can actually find the measure of this angle because we have the ratio. And I'll just put my work down here. So since we have the adjacent and we have the hypotenuse, that would be the cosine. So the cosine of x degrees is equal to the adjacent divided by the hypotenuse. And then just substituting in adjacent side on this, in this problem is 5, the hypotenuse is 8. If you wanted to change that to a decimal, you could. And so now I'm going to use my inverse function to find the angle, and that's the cosine inverse. So the cosine inverse of this ratio, 5/8, is equal to, and that's degrees, that's equal to x. And if I go to my calculator now, and do, instead of doing cosine, I'm going to do the cosine inverse. And then I just have to put in the ratio that I want to change into an angle. Press enter. And again, you need to make sure you're in the degree mode, but it says it's going to be about 51.3 degrees. So x is about 51.3 degrees. Okay. This, I'll get you started on the next one, and then I'll let you finish it, and then I'll let you try the last one on your own here. So the next one, we are given the opposite side and the adjacent side. We're not given the hypotenuse. So that would be the tangent. It uses those two. So the tangent of x degrees is equal to the opposite divided by the adjacent. And so we can substitute in those values. The opposite is 12, the adjacent is 15. You could simplify that if you want, but you really don't have to. So now I'm going to use the tangent inverse to find the angle. So the tangent inverse of this ratio is equal to x. And now I'm going to go to the calculator. And I'm going to do the tangent inverse. And the ratio is 12/15. And that gives us about 38.7 degrees. All right, if you want to go ahead and try 35 and then try the problem on the next page, I'll check back with you. All right, so we're going to use trigonometry to solve a problem now. It says suppose a plane takes off at an angle of 42 degrees with the ground. So let's think of this as the ground. And then the plane is taking off and flying. And that angle is 42 degrees. And then it says what horizontal distance has the plane traveled when it reaches an altitude of 30,000 feet. So 30,000 would be this altitude right now, and we want to know how far it's gone with respect to the ground. All right, and we know that it's flying at 42 degrees. So with respect to that angle, we have the side opposite and the side adjacent. So we're going to use the tangent for this problem. The tangent of A is equal to the opposite divided by the adjacent as a ratio. So let's substitute in our angle, 42, and our opposite is 30,000, and our adjacent is x. And then let's use cross products property, and we get x times the tangent of 42 degrees is equal to 30,000. And then solving for x, we're going to divide both sides by the tangent of 42. And we get that x is equal to 30,000 divided by the tangent of 42. So on our calculator, we're going to do 30,000 divided by the tangent of 42. Again, remember to make sure you're in the degree mode here. And that gives us approximately, whoops, I hit the tangent inverse, sorry about that. Let's try that again. 30,000 divided by tangent 42, and that's 33,318. So x is about 33,318 feet to the nearest whole foot. All right, you try that. All right, that's it for this lesson. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.